All right, so for this last unit, okay, the last unit is kind of a hodgepodge of everything. Okay, we talk about a lot about energy, but we also talk about global systems. So there's some biology kind of scrunched in there. There's a little bit of chemistry. It kind of pushes everything together and kind of shows you how the 3 units we've done thus far are tied together. All right, so what we'll be starting with today is climate. Right, you probably heard climate before and all that kind of stuff, but we're going to be going over kind of what climate is, what are some factors that can affect it, because what we need to look at is the relationship between energy and climate, right? Obviously, the warmest parts of the world are where? At the equator, okay? And they're at the equator because the equator receives the most energy. Right, so we have the warmest climates there. As you go away from the equator, obviously the climates get cooler, okay, because we receive less energy. So we're going to look at kind of the relationship between that today, and then tomorrow, okay. We'll be going over kind of the interrelationships in a little bit more detail between all that stuff. Wednesday, you write your test. Thursday, okay, we'll be looking at climatograms. We'll look a little bit at them today. We'll probably do an activity on that Thursday, Friday, okay, and kind of take it from there. All right, so that's where we're going to be headed. We will be done this unit in plenty of time. So expect that you'll probably write a unit exam on this unit somewhere around the 11th or 12th of June. Somewhere in there. We'll have almost a week worth of classes for final exam review. All right, so lots of time for final exam review in there. Okay. All right, so key points for today. We got to look at what are the components of climate. If we describe the climate of an area, what kinds of things do we describe? Okay, that's what we'll be looking at first. Then we're going to look at the factors that affect those 4 components. What kind of things make the 4 components of climate the way they are? Okay, what makes some place dry versus some place wet and things like that. Okay, we'll look at the effect of climate on plants, animals, and humans. Mostly we'll be looking at this place is different than this place for this reason. Okay, we'll look at energy inputs and outputs of various systems. Okay, mostly for basically every ecosystem except for a very select few. The input source of energy is the sun. Yeah, right. Basically everything on Earth runs on solar power. Okay, if we're talking about a natural system. Okay, we've got photosynthesis converting solar energy into chemical energy, which drives everything else. Okay, everything else runs on the chemical energy plants produce. So we'll be looking at that a little bit, and then we'll be talking about climatograms and how we can read climatograms. That's just a graph that shows the climate, temperature, rainfall of an area, okay, and what that can tell us. Questions so far? Okay, so starting off, climate. The definition of climate is the prevailing weather conditions at a location. Okay, prevailing weather conditions, not the current weather conditions, not the conditions 5 hours from now or tomorrow. Okay, what can I expect on a particular day in this place? That's climate, the prevailing weather conditions in that location. All right. This is something that many people do not understand, including Leonardo DiCaprio, especially Leonardo DiCaprio. Okay, he's an actor. You should stick to that. He doesn't understand science at all, okay, because he thinks a Chinook is climate change. Okay, that's a weather change. And it's perfectly normal, and we see it all the time. If it scares you, go back to Hollywood and hide. Okay, we get them all the time here. All right, that's not climate change. Yes, it's a very rapid change in weather, and if you've never seen one before, maybe it's scary. I don't know. Then what? Like dust bunnies scare you too, probably. But whatever. Okay, some people are easily frightened. But it's just a weather change. Okay, what we saw was a short-term change in the local weather. Climate change means that the weather now is not the way it was. If I look ahead, or sorry, the weather now is much different than the weather was 30 years ago. If that's the case, that's climate change. Okay. If let's say, for example, December is a lot warmer and wetter now than it was 30 years ago in this location, that is climate change. Okay. That would mean that the prevailing weather is different. Okay. And the expectations for that particular time and place are different. All right, but just the fact that the temperature changes during the day is not climate change. Temperature naturally changes during the day. All right, does everyone follow the difference there? Okay, so climate is what can I expect in this place at this time, right? The prevailing weather. So if we're talking about Okotoks right now, okay, Okotoks at the end of May, we could expect that it's going to be, reasonably sunny. The wind will probably be from the southwest. It'll be about 25 degrees, okay, and so on, right? Probably there's a low chance of precipitation at that time. Right? That's describing what we would expect the prevailing weather conditions to be here at that particular time. Right? Everybody okay with that? Okay. So the major components, when we describe the climate of an area, we describe 4 things. Temperature. Okay? That's kind of the obvious one. Okay? We would describe temperature. We would describe precipitation. Is it wet or dry? Snowy or rainy? Okay? How much light is that particular area going to get? And windy. Is it going to be windy or not? And what direction is it prevailingly coming from? Okay, so if we describe, like we say, for Okotoks, wind is typically out of the southwest, around 15 kilometers an hour. Okay, on this particular day, we're going to get about, let's say, 14 hours of sunlight. Right, the days are quite a bit longer here. During this time of the year, if I taught you this in January, I'd be saying the exact opposite. We're going to get 14 hours of darkness, okay, because light changes throughout the year because of our latitude. Right? Precipitation, May isn't a really wet month typically for us. Okay? June actually tends to be our wettest month in Okotoks and Calgary area, and it tends to be our wettest month by a fairly significant margin over all other months because that's thunderstorm month. Okay? We get more thunderstorms in June than we get in any other month, so we get higher levels of rainfall. Okay, and then, like we say, temperature, what do you expect the temperature to be? So the components of climate, the 4 things we describe are temperature, precipitation, light, and wind. Does that lend itself easily to a multiple choice question? Definitely. Okay, so definitely know those 3 things. All right, the interaction of these 3 things is what produces local weather, right? So we can see in this picture here, this is taken on a nice summer day, okay, kind of late July, early August. And what do we see building? Yeah, we see a thunderstorm building, right? We get these cumulonimbus clouds that are getting taller. Okay, that's the interaction of all of these things. In order to get a thunderstorm, you need certain conditions to be present. Okay, it needs to be pretty warm. You typically don't get thunderstorms on cold days. All right. You also are going to get some precipitation, but there has to have been some precipitation as well. There has to be water vapor that's going to be able to build these clouds and produce the storm. Okay, there's got to be light. All of this is solar driven. Okay? Without light, we don't have any evaporation of water and making water vapor that can make the clouds. And typically, on a day when we get a thunderstorm, it's calm through the building phase of the day. Right? If it gets too windy, the formation of those clouds actually is disrupted, and we don't typically get a thunderstorm if it's really windy. Okay? Everybody kind of follow there. Right? So it's an interaction of all of those things. Now, for this storm to build, okay, as we said, we have to have, at least early on in the day, a lot of water vapor being put into the atmosphere. So a solar-driven evaporation of water. As that water vapor goes up, it cools and it condenses back into liquid water. Tiny little droplets. Okay, microscopic in fact. That's what forms clouds. Okay? Clouds are essentially just suspended water droplets. The cloud gets taller because those water droplets try to fall back down, but they can't, because there's so much warm, moist air moving upwards. It'll actually keep that stuff aloft. Okay? And each time more water vapor is put into the air and these other droplets are trying to fall down, okay, you get the cloud getting taller because these water droplets just get pushed a little bit higher and a little bit higher and a little bit higher. And eventually you get these really tall cumulonimbus clouds. Sometimes they're even flat on the top. Okay? You guys remember seeing those in the summer? Okay. The more times that can happen, the bigger the water droplets will get, because each time they get pushed up, more vapor can condense onto the existing droplets. Okay, so essentially that means you get bigger and bigger raindrops, and you probably noticed that during a thunderstorm, sometimes the raindrops are really, really big. Okay, and sometimes they're really, really hard. Yeah, because they're hail, right? The same process, if you've got a lot of water vapor moving upwards, can actually keep water drops that are big aloft and push them above the freezing point. So they will freeze. And then when they try and fall back down, they get pushed back up and more water vapor freezes onto them, making the hailstone get bigger and bigger and bigger. Anyone ever broken open a hailstone? Next time it hails, get a big one and break it open. It'll look like an onion. It'll have layers. Okay, and you can actually see the growth of the hailstone. Okay, a hailstone's the size of a golf ball, have 5 or 6 layers inside. Okay, and that just represents all the deposition of water vapor freezing onto the hailstone. Okay, so to get golf ball sized ones, it has to have gone through the cycle a few times. Okay, I've seen in Wainwright, actually back in, I think it was what, 2003, 2004, they had softball sized hail. Okay, like it wrote off, all the car dealerships in that town wrote off their entire inventory that year. Okay, it destroyed all of the vehicles, brand new vehicles out on the lots, all destroyed. Okay, totally wrecked. People's houses, like there were holes in people's roofs, windows were broken everywhere. Okay, it was crazy, and there were these big softball-sized hailstones on the ground. Okay, it was crazy. Okay, if you were outside in that, you would have, there was like, you were seriously in danger of being killed. Okay, these things were so big. All right, if they'd hit you in the head, they could have knocked you unconscious. Okay, so it was a very, luckily it didn't storm like that for very long. Okay, the softball size ones were very short-lived. Okay, most of them were golf ball size, okay, but they were hard. Everybody with me there? Okay, there's actually a old urban legend, I don't know if it's true or not, but it's scientifically plausible, that in World War II, a pilot bailed out of his crippled bomber into one of these, and when he opened up his parachute, the parachute got sucked up into the cloud, and he came down encased in ice because it kept freezing onto him as he went through the cycle. It's plausible. It's not likely. It's plausible. Okay, that's what the Mythbusters would say about that one. Plausible. Okay. So anyway, that's an interaction of, again, all 4 of those components of climate. In order to get that kind of weather, the 4 components have to be of certain types. Okay. In the wintertime, we get big winter storms because the temperature is low. Okay, there's some water vapor in the air that's interacting with really cold air. Okay, there's not a lot of light, so that keeps the temperature down, and usually it'll produce a lot of wind, and we get like a big blizzard or something like that. Lightning is the result of all those particles that have been pushed up carry charges with them. If you get a massive imbalance of charge, then the charge wants to balance itself, and the charge balancing itself is the stroke of lightning coming down and hitting the earth. Okay, so the electrical charges balance out by grounding out onto the earth. Don't get in the way of that. Okay, it's not good. Anyone ever been near a lightning strike? Yeah, it's terrifying. Okay, to actually be close to one, when it hits a tree, the tree explodes. Okay, it actually hits the tree, and the sap inside the tree will just boil, and it just expands and it blows the tree apart. It looks like someone put a stick of dynamite in the tree. Okay, it's nuts. And if you've ever been around when one's about to strike, all the hair on your body stands up, like on end. I've been near it several times and just looked down at my arms and went, oh crap. Okay, at that point you just lay down on the ground and pray, because that's about all you can do. Okay, don't stand up. You want to be nice and low. You want something else to be higher than you. Okay, because if you get hit, you're probably not going to make it. It's really hard on you. Okay. All right, questions on the 4 components of climate? Okay, in Okotoks, what are some things that make our climate the way it is? What are some things that affect our climate? Okay, the mountains are a big one. Okay, the mountains create what we call a rain shadow, right? That is that as water vapor is coming in off the Pacific Ocean, it gets pushed up on its way over the mountains. And when it gets pushed up, most of it condenses and falls as precipitation in BC, okay, on what we call the windward side of the mountains. And by the time it gets over the mountains to us, it's actually quite a bit cooler and drier. Okay, as it comes down the mountains, it'll pick up speed and it'll increase in temperature, and that's a Chinook. Yeah, warm, dry wind coming off the mountains. All right, so the mountains influence our climate a great deal here. What else? Yeah, to some extent. I mean, landforms, like we say, can cause changes in weather. Certainly, the mountains are a big factor for us because it's flat here. Yeah, wind can travel without interruption. Yeah. Yeah, bodies of water or the lack thereof. Okay, there really aren't any big bodies of water near us. Okay, we're landlocked. We're a long way from the ocean. Okay, all the lakes around here are small. Okay, what else? Why do we always want to go somewhere else in the winter? Why is it warmer somewhere else? Exactly, latitude. Okay, latitude makes a big difference. We're quite a ways from the equator. We're more than halfway to the pole, okay? Considerably more than halfway to the pole, right? So it's considerably cooler here, okay? And that causes length of day to change throughout the year. That's what actually causes the seasons. All right, number one factor affecting climate is your latitude. That is your position on Earth in relation to the equator. Okay, the reason that is the number one factor is it affects everybody. If you're at the equator, it's nice and warm. If you're not, it's a little cooler. Okay, and that is due to the intensity or directness of your sunlight. Okay, so inputs of solar radiation decline rapidly away from the equator, and here's what we mean. At the equator, okay, when a certain amount of sunlight strikes the equator, it is concentrated on an area the length of that blue line I've just drawn. As I move away from the equator, that same amount of sunlight is now spread over a larger area. So is it as intense? It's not, okay? And this would be like, so right here around like Mexico, right? We're way up here. Whoa. Okay, that same amount of light is now spread over a much larger area, okay, which is why it's much cooler here than it would be at the equator. Now, obviously, we're in summertime right now. It's quite warm here. Not quite as warm as it would be at the equator, but pretty close. So why does it change for us? Okay, what do you mean by positioned? I see you doing this. It's, yeah, yeah, exactly. The Earth is actually tilted quite a bit. The Earth is tilted 23.5 degrees. Okay? That's like a quarter off vertical. All right, like vertical would be 90 degrees, right? We're 1/4 off of that. So the Earth kind of wobbles back and forth like this throughout its orbit, right? And what that does is it causes massive changes in the amount and quality of sunshine. So the Earth looks like this, straight up and down, 2 days a year. It looks like this on the spring equinox and the fall equinox. Okay, it is perfectly straight up and down, and we get 12. Every place on Earth gets 12 hours a day and 12 hours a night on those 2 days, and that's it. Okay, every other day throughout the year, day and night are not equal. Okay, so there's only 2 days where they're exactly equal, because in the winter time, for us, when it's winter, the Earth is tilted like this. We're tilted away from the sun. So now, instead of being here, we're way up here. Okay, so what's the now? Is that same amount of sunlight spread even further out? Okay, even further out. And remember, the sun only hits us when we're over here on the sunny side. The Earth is spinning like this. Okay, it's spinning around its axis like this, so we don't get into the sun very much, which means our days are very short. Okay, December 21st, okay, the winter solstice, shortest day of the year, is when the Earth is tilted the most for us away from the sun. If you were in New Zealand or Australia, that would be your longest day of the year, okay, because you'd be tilted towards it. So it's their summer when it's our winter. Okay, right now, we're moving the other way. Okay, right now, we're moving towards the summer solstice, okay, at which point we're pointed towards the sun. All right, so we are down here. We get much shorter nights. And if you're at the pole, you get endless day. Right, the sun never goes down because they're pointed towards the sun and they never get into the darkness. All right, you get 24 hours of sunshine, no hours of darkness. It's great if you're a little kid and your parents say, come home at dark. You come home in August. Okay, well, it's not quite August, but it's like middle of July for sure. Okay, and it would only be dark for like 15 minutes. Okay, the sun does this weird thing where it just circles overhead. Okay, has anyone ever been to the north in summertime? It's really, really weird because the sun just does not go up and down. Okay, the sun literally goes like this in a circle, okay, and you can watch it. It's really weird. Okay, and it obviously never goes down. Right, so it actually can be very difficult to sleep in the summertime in the north because it's never dark. Okay. Yeah, in December. Well, from like middle of November to middle of January, the sun never comes up. It's just dark all the time. They call it the dark days. because it's literally 24 hours of darkness. The sun never comes up. Okay, and then for a few weeks you'll get like 15 minutes of daylight and so on and so on. Okay, it's really, really odd, okay, to be in those places when that's going on. All right, but that's because of latitude. Okay, not only is the Earth tilted, okay, but different latitudes get different amounts of sunshine, and that's what causes temperature variations as you move away from the equator. All right, okay, at the equator you don't notice the effect of this tilt nearly as much. Okay, the temperature is pretty much the same all year if you're near the equator. Length of day is pretty much the same. It doesn't change a whole lot. Okay, I remember going when my sister got married, we went to Hawaii for that, and the lady at the desk in the hotel was complaining about how short the days were getting. I'm like, are you kidding me? Like, what's your shortest day? She's like, about 11 hours and 15 minutes. Like, do you even notice a change in daylight of like an hour over 6 months? That's the stupidest thing I've ever heard. How about you come up to Canada in December and tell me about how short the damn days are, okay? Because that's absolutely ridiculous, right? Their length of day doesn't change very much, right? But at the same time, if you've ever been down there, okay, it doesn't matter what time of the year you're down there, the sun goes down between 6:30 and 7 o'clock, comes up between 6:30 and 7 o'clock in the morning, right? It's always about 12 hours long. Okay. Questions on latitude. Okay, so latitude is a factor that affects climate. It affects light. It affects temperature. Not too much effect on precipitation and wind, though. All right, so it's a major energy kind of changer. All right, so is altitude. Okay, altitude affects, to some extent, precipitation, a big effect temperature, and to some extent a bit of wind. Okay, it does not affect light. Okay, altitude has no effect on light. On average, every 1,000 meters of elevation you gain will result in about a 6-degree cooling in temperature, which is why snow stays on top of the mountains longer than it stays anywhere else. Okay? So on average, you're going to see about a 6-degree change in altitude, or sorry, in temperature for every 1,000 meters up you go. And if you've ever done any hiking or backpacking in the mountains, okay, you know this to be true, right? This is a picture that I took when on a backpacking trip with my father. Okay, we started out the day, well, it's not in the picture. It's in this valley that would be like down there somewhere. Okay, it was at an altitude of about 1,400 meters where we started. Okay? It was about 16 degrees and it was raining. When we got up to here, this is Snowbird Pass. Okay. The temperature was about 7 degrees, and this was an altitude of about 2,500 meters. Okay, so we'd come up 1,100 meters. In the background here, you see Mount Robson. It's the highest peak in the Canadian Rockies. The top of it, okay, on that particular day, okay, was well below zero, and there was a blizzard going on. Right? We actually walked up a little further than this, and we got into the point where the temperature had dropped to near freezing. The rain was changing to snow, okay, at that point. But the higher up we got, the colder it got, and it was almost exactly 6 degrees per 1,000 meters. That's not always a hard and fast rule, but that's what it is on average. Okay, the higher up you go, the cooler it's going to get, and the more disruption and effect of like the jet stream and things like that you can get the higher up you go. Okay. On this particular day, 2 people were actually blown off the top and fell to their death, okay, on the top of the mountain. That's why you don't climb in a storm. Okay? Only stupid people climb in a storm. Go back down, you try it another day. Okay? It doesn't do any good to get to the top if you can't get back down to the bottom. This is the lesson all climbers must know. Okay? You see this? How many people have ever watched all the Everest, like some Everest documentary or K2 documentary, right? When do most people die? On their way down. They almost all die on the way down. Almost nobody dies on the way up. Okay? They almost all die on the way down because they went up and they stayed up too long. Okay? And then as a result, it got windy, the storm, the weather came in, whatever. Okay? If you can't, doesn't matter if you get to the top. If you don't get down, you can't tell anybody. Okay? You don't get to brag if you're dead. Everest. Yeah. Oh, no. Kilimanjaro is the highest one in Africa. Yeah. Kilimanjaro is the highest one in Africa. But no, Everest is by far the highest. It's another 500 feet or more taller than K2, which is the second. All right, so altitude, like we say, big effect on temperature, some effect on precipitation, okay, and an effect on wind, but no effect on energy. All right, distribution of land and sea. The ocean has an incredible ability to regulate and thus affect your climate. Okay? Because the ocean is obviously made of water, and water can hold a lot of heat. Because it can hold a lot of heat, it can keep the temperature of an area stabilized. Okay? And that's because of the second law of thermodynamics. Energy always flows from hot to cold. So if you're, let's say, in Victoria or Vancouver, okay, you're obviously fairly high latitude, but you're right next to the ocean. And because of that, if the air temperature starts to drop, it can't drop very much below the temperature of the ocean, because once it does, energy starts to come out of the water back into the air, according to the second law of thermodynamics. So very rarely can the air temperature get much colder than the water temperature. Now, if you've ever gone in the ocean off the coast of BC, you know that that ocean is not a warm ocean. Okay, that's why you can always tell Canadians in the tropics. We approach the water differently. Okay, like in the tropics, you can always tell the Canadians approach the water like this because we just expect it to be cold. Okay, it's not going to be, but we just expect that, okay, because that's what we're used to, right? But yeah, if you go into the ocean in either place, if you go off the east coast, off the west coast, the water's cold, right? But it does help to regulate the temperature of the air, okay? And especially on the west coast, where the ocean doesn't freeze over, okay? It has a much greater ability to regulate the temperature, which is why it's very temperate on the coastal parts of BC. Okay? The ocean can regulate the temperature because of all the energy it can hold. Right? Now, the same is not really true over on the East Coast. Okay? And the reason for that is the ocean currents are different on the East Coast. Lots of cold water comes in from the Arctic, and the parts of the ocean on the East Coast can actually freeze. Okay? Near the shore anyway, okay? They can actually freeze over, which then removes their ability to regulate the temperature, because once the ice freezes over, snow can collect on top, okay? And then you don't get as much regulation, which is why Newfoundland, even though it's a similar latitude, is colder. Okay? It's right next to the ocean, but it's colder. Okay, so the distribution of land and sea, how close you are to the ocean, can affect your temperature. It can also affect your precipitation massively because, well, you've got all this water that can evaporate and create rain and storms and things like that. Okay, hurricanes, yeah, if you're at the right latitude, right? We don't get hurricanes in Canada unless we get the tail end of a really big one as it dies out. Okay, but you have to be near the equator to build a hurricane because you need all that energy. Okay? But then the nature of ocean currents is also a big part of it. You can see that the ocean currents coming in on the west coast, okay, come from basically straight out to the west. All right, and they actually over here kind of turn down a little bit, so they're bringing water, okay, to that area. Whereas over here on the east coast, you can see that we've got the Labrador current, okay, that's coming in. It interacts a little bit with the Gulf Stream and stuff, but mostly you've got cold water near the shore, okay, coming from the Arctic, making that water temperature quite a bit colder. All right, El Nino and La Nina are also ocean currents. Some people have heard of those before. Okay. And when we get an El Nino year, it's typically a year where winter is very mild. We don't get a lot of snow. Summer's quite hot and things like that. And when you get a La Nina year, you get the exact opposite. La Nina usually follows El Nino. Okay. This year was more of a La Nina year. Right. We had a longer, colder, we had more precipitation this winter than we had last year. Okay, which was obviously hot and dry. Okay, it was an El Nino year. Okay, those happen on about a 7-year cycle. Okay? And it's actually from an ocean current down off South America. Okay? An ocean current down off South America can actually cause global temperature changes of several degrees. Okay? Now, I know you're thinking several degrees, 2 or 3 degrees isn't a big deal. But when you think about how much water is changing temperature, we're talking about all the water on Earth changing temperature by 2 or 3 degrees. That is a massive amount of energy. Okay? So these ocean currents can affect global climate from year to year. Mm-hmm. Yeah, you get enough stuff into the atmosphere and you block enough solar radiation. Yeah, like a big volcanic eruption can certainly affect global temperatures. Okay, so distribution of land and sea, closer you are to the ocean, the more chance you have of having more precipitation because there's more water vapor available, okay, but also regulation of temperature, right? Nature of ocean currents, if you're near cold water currents, it's going to be a colder climate. If you're near warm water currents, it's going to be a warmer climate. okay, which is why off like Florida and places like that, okay, all along the eastern coast of the United States, they get hurricanes. We don't. Okay? We don't get hurricanes there because we don't have these warm water currents. We don't have all this energy associated with the ocean, okay, to build up these big storms. Right? And obviously, the last few years, we've had far more large destructive hurricanes than ever before. Okay, questions there? Are you good with that? Okay, and then distribution of mountain barriers. So this was one of the first ones that we talked about. Okay, things that affect our climate. Definitely, the presence of the Rocky Mountains affects our climate a great deal. Right? For reasons of, okay, over here in the Pacific Ocean, water evaporates off the Pacific Ocean, and because we're in this part of the country, okay, we get wind that blows it to the west, or sorry, to the east from the west. Okay, that means it blows it onto the mountains and up and over. As it goes up and over, it cools. Most of the water vapor condenses and falls as rain or snow on the windward side of the mountains. Okay, so we call this the windward side because the wind is hitting it, right? By the time it gets up and over, we've got cool, dry air now moving down the mountainside. As it moves down the mountainside, it rubs against the mountain. There's some friction and heating. It gets to lower altitude, so it picks up heat, okay, and comes off that mountain as warm, dry air, okay? In other words, the thing Leonardo's afraid of, okay, one of those. And this is typically called the leeward side. Okay, so if you are in the lee of a mountain, or of a mountain range, you are typically going to be in what we call a rain shadow. Okay, so this here, okay, we are in the rain shadow of the Rocky Mountains. Okay, if you look down at like Arizona, Utah, Nevada, they are also in the rain shadow of the Rocky Mountains, and you get deserts in the back. Okay, there is a massive desert behind the Himalayas as well. Okay, the Gobi Desert. It's a high altitude cold desert, but it is very, very dry because again, stuff doesn't get over top of those mountains. They're very, very tall. Okay, you see the same thing in Hawaii actually. If you've ever, how many people have been to Hawaii before? You ever notice how one side of the island is all tropical rainforest and the other side's all desert? Okay, it's totally true on every single island. One side's on the windward side, all the precipitation falls there, and the other side's all dry. Okay, so you see that the mountains, high altitudes, okay, can really cause things to dry out. All right, question on the mountain barriers. Okay with that? Okay, patterns of prevailing winds. Okay, your prevailing wind direction is determined by your latitude. At the equator, or near the equator, okay, essentially below 23.5 degrees or so, okay, the winds are typically from the east. Okay, we call them the trade winds, but they are easterly winds. They blow from the east to the west. Okay, they're called the trade winds because they brought the trades from the old world to the new world. That's the winds that was used to come across the Atlantic Ocean, okay, from the original countries to the colonies back in the day when that's how you came across the ocean. Okay, at our latitude, we are in what are called the westerlies or the mid-latitude westerlies. Okay, so our wind typically comes from the west, but we are right at the upper edge of that. Okay, we're at the upper edge of the westerlies latitudes, which is why sometimes we can get wind that comes from other directions. Okay, if we've got wind that comes out of the northeast, are we in store for anything? What happens when we get wind from the north? It gets cold. Right? If we get a northeasterly wind here, man, we're in for something because all that can bring is nasty. Okay, it can bring cold, it can bring rainy, okay, all that kind of stuff. So when wind does that, okay, we know we're in for something. And then up near the pole, we get what are called the polar easterlies and just kind of circles around the pole. Okay, so that's why once in a while we get northeasterly winds because at our latitude, so this would be kind of where the end of the trade winds would be. This is kind of the end of where the westerlies would be, and then up here would be the polar easterlies. So sometimes we get, winds coming like this from the west to us, and at the same time we've got something from the north doing this. When they meet in the middle, okay, that's when we get all kinds of crazy stuff happening, okay, big storms and things like that. Winds come from either differences in temperature and or pressure. So if there's massive pressure differences, then you get winds. That's what causes a tornado. Okay, during the day when a thunderstorm is building, you've got all this warm, moist air moving upwards. So you get this massive temperature or pressure differential between ground level and high up because all of the stuff is held high up. And then the way to quickly balance that is to make a funnel that quickly balances the change in pressure, causes wind. Yeah. Okay, so areas of high and low pressure. There are some places on Earth that are just always low pressure areas, low atmospheric pressure, typically wetter, okay, and some areas that are just always high pressure areas and typically drier, right? Right over top of, okay, kind of the northern parts of Canada here is what's typically called the Siberian High, right? Because it's cold and it's always a high pressure area, right? So it's typically clear, sunny, cold. Over here, in kind of the armpit of North America, okay, between like Alaska and the Yukon and stuff, is what's called the mother low. This area is almost always low pressure, right? Which is why right in that area is some of the wettest places in North America, okay? Because there's always this influx of water vapor from the ocean, and low pressure to keep that can't keep it up in the air, can't keep it as a vapor, so it's always falling as precipitation. Now, the interaction of these two things causes, like we said, this area to be very wet and this area to be very dry. But there's a problem. These two pressure differences can cause systems to move off of them. Okay, so circulation around a high is counterclockwise. I always get that backwards. Maybe it's not. Anyway, okay, so air typically rotates this way around the high, and it rotates this way, clockwise, around the low. And so what can happen is a big kind of moist air mass would come off of this low pressure area and start tracking down the mountains like this, okay? And you get a cold air mass coming off of this, and where do they meet? They meet right down Highway 2, and they track right down that highway, right? Is that where some really funky weather can happen? Like in the wintertime, that's where Highway 2 gets closed, like right like Red Deer Olds kind of area. That seems to be where everything meets. Okay. In the summertime, that's where we get the worst storms, the most tornadoes, the most hail. Okay, is always in this area because these two pressure systems are interacting. Okay? That's typically where they meet. Okay. If Canada had a tornado alley, that would be it right there. Okay, that's where it would happen. Right. Obviously, the U.S. has the tornado alley, and it's actually just an extension. I shouldn't have erased that. Of that one. Okay, it goes right down to like Kansas and Oklahoma and places like that. Okay, Iowa. Yeah. Okay, questions on those two. Okay, so patterns of prevailing winds obviously affect wind, okay, as one of the components of climate, but they can also affect precipitation, okay, and they can affect temperature. They don't affect light though. Okay, and locations of high and low pressure can affect temperature, precipitation a lot, wind a lot, okay, have no effect on light. Okay, really only latitude can affect light. All right, now talking about climatograms, okay? A climatogram is a graph that shows me the temperature and the precipitation by month for a specific location. Right? So a climatogram is essentially two graphs superimposed on each other. Okay? So what we have here, okay, is we have bars that represent precipitation. We have a line that represents the temperature. So there's actually two y-axes on this graph. Okay? The axis on the left is the precipitation one. Okay? The axis on the right is for temperature. Everybody with me so far? Okay. So this place here in this first graph is a tropical rainforest. Tropical rainforests typically exist near the equator. All right. And near the equator, we get about the same amount of sunlight, okay, all year long because we don't have the latitude having much effect. We get very direct sunlight near the equator. So we get warm temperatures, okay, all year long that don't fluctuate. Okay? The temperature is basically the same all year because, again, the amount of sunlight we're getting doesn't change very much and the length of day doesn't change very much. Right? And we can see that precipitation changes a bit throughout the year, but it's generally quite high. To give you an idea, their driest month here in Manokwari, New Guinea, okay, gets about 11 centimeters of rain. Okay, so that's their driest month. They get that much rain in their driest month. In their wettest month, okay, they're getting 32 to 35 centimeters of rain. So, okay, it may not seem like a lot, but guys, in 2013, when we had all the flooding, we got this much in a month. Okay, so yeah, if you're getting this much in a month, it's going to be kind of, well, flooded and wet. Okay, that's why a tropical rainforest can exist there, but not here, right? Our typical monthly precipitation is something like this. Okay, our wettest month is June, and typically we're looking at about 10 centimeters of rain in June. Okay, beyond that, most of our months are pretty dry, including the winter. Okay, you're probably all thinking, yeah, well, Codere, like we had a couple of storms this winter where we got this much snow. Does snow represent the same amount of moisture as rain? Actually, 1/10. So for every 10 centimeters of snow you get, that represents 1 centimeter of rain. So those days when we got 30 centimeters of snow, okay, that only represented this much rain. Okay, it doesn't actually represent all that much because snow is fluffy, right? There's lots of air spaces in it, so it doesn't represent a lot of moisture. Okay, so we notice here, at least for an equatorial climate, and this is a pattern that we need to know, you might want to make a note of this, okay? An equatorial climate will have a flat temperature line. Okay? There's not really any pattern to precipitation based on latitude, okay? But for temperature, an equatorial climate has a flat temperature line. Right? These other two have bell curves for their temperature lines, which means we've moved away from the equator and we now have distinct seasons. Okay, so if we're looking at a mid-latitude place, so Nashville, Tennessee, so down kind of mid-latitude United States, right? We're seeing that the temperature does change quite a bit. In their coldest month, it only gets to be about 5-6 degrees Celsius. Okay, but in their hottest month, it's 28 degrees Celsius. So they got a definite summer and winter, and then like a fall and a spring as well. There's definite seasons. Right? So the further away you move from the equator, the more pronounced this bell curve will be. Not only more pronounced, but its location will change. Right? So you can see here in Tennessee, this bell curve is placed fairly high. It doesn't get below freezing. Here it is for Alaska. Notice the position of the bell curve is much lower. Right? In winter, it's much colder, and summer, it's much cooler as well, about 15 degrees. Okay? So those are the things to watch for. If you see a bell curve, you know you're not looking at an equatorial area. And depending on the position of that curve, you could be looking at a polar area or a mid-latitude area, depending. All right. For rainfall, okay, so we're looking at a mid-latitude deciduous forest. That's forest where the plants lose their leaves every year. It'd be like oak and hickory and stuff like that. Okay, you can see here that the rainfall is actually fairly regular. Okay, the driest month is 8 centimeters, the wettest month is 13. So not much of a difference between driest and wettest month. Having nice even precipitation like that is what produces good forests and things like that. Right? To give you an idea for Calgary, okay, our precipitation bars actually follow the temperature curve. Right? We get the highest precipitation in June and then it tapers off in the winter. Right? For Anchorage, Alaska, not a very wet place. Okay, its wettest month gets about 7 centimeters of rain. Probably at this point, this would be snow. Okay, and its driest month, okay, is April apparently, where it gets only about 1 centimeter of rain. Okay, so it can get pretty dry, which is why you get a very different type of forest there. You get like the coniferous forest, all the pine and spruce, whereas in Nashville you get more deciduous water-needing trees. Depends where you are. There's a definite change in the desert between like day and night, but if you're in the Sahara, it's not dropping below freezing, right? Like certainly during the day, it could be 50 degrees Celsius, and at night it might drop down to 20, right? Well, if you were used to that, 20 would seem pretty cold, right? For you or I, we'd die in the daytime, and in the summer, in the nighttime, we'd be like, sweet, it's awesome out here. Okay, 20 degrees is like tropical for us. Okay. But yeah, it does change a lot. There are some deserts, high altitude deserts, where yes, it can get very, very cold, but it doesn't also get very, very warm during the day. So it all depends on where you are. yes, there's a big change. Okay? And there's a big change because there's not a lot of water around to regulate that change. Yeah. Okay, so does the climatogram stuff make sense to everybody? Because we're actually going to do an activity on that, and actually on your unit exam, okay, one of the things I always do is I put a climatogram on the unit exam, and I ask you, where do you think this climatogram came from? Explain your choice. Okay, so you'd have to look at it and go, oh, well, it's got a flat temperature line, so it must be somewhere equatorial. That would take out that it's certainly not like Calgary or Alaska or something like that. So you'd be looking for a more tropical location. Okay, so I will ask you to do something like that with the climatograms, and we'll be working on that later on in the week. All right, I want you guys to answer those questions. Complete sentences, please. Okay, put some thought and detail into those answers, and we'll go over them together here in a little bit. Okay, let's go over these. So question number 1 is list the components of climate, describe them as you think they are in central Alberta. Okay, so the components of climate are wind, temperature, light, and precipitation. Okay, basically the things you'd want to know if you looked at the weather in the morning. Okay, you'd want to know whether it was going to be windy, whether it was going to rain or not. Okay, whether it was going to be sunny or not, and whether it was going to be windy or not. Okay, those are the things you would want to know. All right, if we're looking at central Alberta, okay, we would say that the temperature would generally be cooler, right? I mean, obviously in the summertime it can be warmer, but we could say fluctuates throughout the year. And we would say for precipitation, it would be moderate, at least for this climate, with much of it coming in the form of snow. Yeah, in the wintertime, we're going to get a fair amount of that as snow. In terms of light, we would say fluctuates throughout the year to a minimum in December and a maximum in June. Okay, and wind in central Alberta, okay, would be variable. Sometimes it comes from any direction. Okay, here we're typically more from the west, but if you got up to like Red Deer, Edmonton area, okay, the wind is like basically any direction on any given day because it's right in a transition zone between easterlies and westerlies, so it can be quite variable. All right, for question number 2, what factors most affect the climate in our area? Okay, here's the thing, guys. It doesn't matter what location on Earth I give you. The first component you should list because it affects everywhere is that's a component, latitude. Okay, latitude is the primary component, or sorry, primary factor affecting the components of climate because it's what determines energy. Right, latitude can be listed as a factor affecting climate for any location, and that's important because I will ask you a question just like this on your unit exam. I will simply give you a place and say, describe the components of climate, and then talk about the factors that affect them. Right. Number 1 factor affecting climate for any location is latitude because it determines how much solar energy you receive. Okay. All right, so we got latitude, number 1. What's probably the second biggest factor affecting our climate here? The mountains. Okay, the mountains is probably the second biggest one for us. Okay, they cause Chinooks, which are a big deal for us. Okay, they make it dry here because they block a lot of the precipitation. Okay, things like that. So mountains would probably be our second one. What would our third be? Altitude. Yeah, definitely altitude. We're at over 1,100 meters altitude here. Okay, that means that if the difference between being in Vancouver and being here, okay, is we are over a kilometer higher here than you are if you're in Vancouver or Victoria. Okay, that means it's typically going to be a little cooler and a little drier at this altitude. Okay. And I would say like maybe a distant fourth might be centers, or sorry, present like location of water bodies. We're not close to any. Okay, we're very far from any body of water, which would typically make it dry. All right. I would say in a question like that, you got to give me at least 3 good ones. Okay, and for this place, we would say latitude, mountain barriers, and altitude would be the big 3. All right, if we're looking at the climate of Saudi Arabia in terms of the components of climates, okay, what's temperature like in Saudi Arabia? Hot, like hellishly so. Okay, it's like 50 degrees there all the time. It's like brutal. Okay, all right, what about precipitation? Not much. This is a desert. Okay, it's like shifting sands. It looks like Tatooine, if you know what I'm talking about. Okay, Tunisia. It's in, yeah, they film it in Tunisia. Yeah, it's bad. Okay, so we got that it would be very, very dry. All right, what else? what would the winds be like? Now, Saudi Arabia is right near the Persian Gulf, so it actually has a lot of winds that blow onto the Gulf as opposed to off of it. Okay, if it was blowing off of the Persian Gulf, it would be bringing moisture. It's not. It blows onto the Gulf. Okay, so we've got winds there that are taking moisture away. Okay, and light. So Saudi Arabia near the equator. Okay, so what's the length of the day going to be like? Yeah, similar all year. It's not going to change very much. Okay, and they'll get high intensity light because they're right underneath the sun. All right, so those are the types of things I would ask you on a unit exam about this particular lesson, okay, being able to apply it, as well as here's a climatogram, explain where it's from, okay, identify where you think it might be from, and then tell me why. Well, it's got a really big bell curve that's very low, so it must be far away from the equator, okay, and its precipitation is very, very low across the board, so maybe it's Tuktoyaktuk, okay, or something like that, which is like way up north, okay, or alert or something like that. Okay. All right. Any other questions on this particular lesson here?